Hello, and welcome to episode 6 of TGI Kubernetes. Hopefully, y'all can hear me fine. Let me know in the comments. You can see how my new comment thing is working here from last week. Today's topic, what we're going to be covering is how to set up a cluster using this tool that we've been working on for a while called kubeadmin or kubeadm. So let's see. Yeah, can y'all? Oh, yeah, great. Thanks for confirming that you can hear me. I'm always not sure. I'm always messing with the setup, so every time I do one of these, I'm pretty sure I'm screwing it up. So yeah, so today, most of what we've been doing up until now has been focusing on using a cluster and how the different concepts in Kubernetes layer on top of each other, and doing some deep dives in things like authentication and RBAC and stuff like that. This time we're going to do a little bit about how what is an easy way and what is the future for how we're actually looking at getting clusters set up. But before we start, I just wanted to just do a quick shout out to the team at Heptio that we just launched 2 new open source projects. They're called Heptio Arc and Heptio Sonobuoy. And I just want to go through, we're not going to do a full demo right now. I will probably save that for a future episode. But if you go to GitHub Heptio Arc. If we look here, so Arc is a utility that lets you back up and restore clusters. And so it manages from the API, so you don't need special access to the cluster, to the etcd server behind it. So it'll work with hosted clusters also. It's a way to capture all the objects that go into that cluster. And if you're running on one of the 3 major clouds, Azure, GCP or AWS, it'll also manage using domain-specific or cloud-specific snapshots and creating and managing those. So this is a start. So we'd love for folks to get a start with this, see what they think, and we're going to be improving this over time as we start looking at all the things that you need to think about in terms of disaster recovery around Kubernetes and what does it take to build a production-ready system that that you can really start betting on. So now the other project that we have here is Sonobuoy, and Sonobuoy is another sort of infrastructure-y project. You run it on your cluster. So first of all, physically, a Sonobuoy is this thing that the military typically can drop out of a plane or out of a boat that is a buoy that essentially uses sonar to map the ocean floor. And so the idea here is that we want something like that for a Heptio cluster. You drop this thing in there, and then it can actually look around and try and understand all sorts of things about the cluster. And over time, whether that cluster is healthy or not, the biggest thing we're starting from right now is conformance. So does this cluster pass all of the tests that we run when we're doing a Kubernetes release? And so you can be sure that you got networking and the control plane and everything else set up correctly if you can pass these conformance tests. And the idea moving forward is that this can be one of the tools that we use so that as people start doing more interesting things with Kubernetes, everybody can be sure that if it passes this conformance test, then you can be pretty sure that you can use it and your tools will work and everything will interop. So this is a really important step for the Kubernetes ecosystem as a whole. So yeah, so quick shout out to those. If you go to blog.heptio.com, we have a blog post that goes into some of the details here around sort of why and how and what we did here. So quick shout out there. And then also on Twitter, let's see, I should have had the thing up here. So Lachlan from Microsoft, he did a walkthrough here on YouTube. So I can play YouTube from within YouTube here. Look at that. Where he essentially goes through and does a walkthrough here. So I will make sure. So this was Sonobuoy. He also did one for Arc. So he just posted the Sonobuoy one like, oh look at that, like 45 seconds ago. Okay, so so we have a Sonobuoy one, and we have an ARC one that he posted this morning. That's a little bit longer, so you can definitely check those out. And thanks, Lachlan, for putting those together. That's really exciting. We appreciate that. I haven't actually seen. I hopefully he has nice things to say about Sonobuoy as he goes through it. I haven't actually had a chance to watch that one yet, but I'll put. Yeah, thanks, Yo, you're watching. I'll put links to both of those in the show notes afterwards so that folks can check it out. All right, so with that, let's go ahead and we'll get started with building a Kubernetes cluster from scratch. What I'm going to be doing here is I'm going to be going everything from launching some VMs. I'm using AWS here to go ahead and do this. And then manually driving kubeadmin to actually make this stuff work. So this is sort of Kubernetes the kind of hard way, right? So we're not using something that that end-to-end sort of spins up resources and installs everything and configures all that stuff. So we're doing a little like sort of the next level down from that, but we're not going all the way down to the level of manually configuring all the various components to run. So. And then as we do this, I'll go into a little bit of detail of what's happening under the covers and what the kubeadmin tool is doing for you. And if you have questions or if you want to go deeper on something, just go ahead and shout out on the chat here and let me know. If you think I'm skipping some steps or I'm leaving some stuff out, you let me know, because ideally we want folks to be able to reproduce this, whether it's on Amazon or any place else, so that they can actually get this stuff up and running. We actually just this week we bought a stack of these Intel NUCs, Next Unit Computings, these super small little computers, so that we could have sort of a bare metal cluster here in the office to actually play with. And it was able to get up and running, very, very quickly using this tool set there. The one thing that I'm not going to be going into and doing a lot of detail around is setting up the integration between Kubernetes and AWS here. There's a lot of sort of fiddly stuff that happens with AWS that you have to set up in addition to Kubernetes to get this stuff working. It's totally doable, but it's probably just going to take too long. And if folks are interested in that, I would definitely say looking at the Heptio AWS Quick Start, you can look through the code there, and that'll have all the details of what we're doing. I also have a Google Doc that I've shared with people that details the AWS cloud provider and what you need to get that up and running. It's been on my to-do list for a while to move that into the official documentation. So that's what we're not doing. So let's go ahead and let's launch some VMs. So I have one up and running already here, but one VM does not a cluster make. So let's launch some new instances here. And I'm going to be going through the the launch wizard that Amazon does here. So hopefully y'all can see this. Let me increase the font a little bit. So we're going to be starting with an Ubuntu 16.04 OS, and so we're going to select that, and then just to make sure that we don't hit any memory issues, I'm going to do a T2 medium here. Okay, Aaron's asking, is there a good source for other cloud providers? The answer is no. Right? It turns out that our documentation in terms of what it takes to configure integrations for various cloud providers is really lacking, and that's something that we really need to do a better job of. If somebody wants to start pulling that together, if you have any expertise here, I'd love to coordinate that. It's actually a real hole in our documentation right now. So I wish I could say yes, there's a great resource. I can just point you to a page. We're unfortunately not there yet, but it's definitely on my list here. All right, so we're going to be doing a T2 medium, and let's see. So we're going to do. I'm going to do. Let's see, 3 more instances here, and oh shoot, which we want to make sure, just for simplicity, we want to make sure that these are all in the same zone. So let me see what zone this was in that I had this thing in. Okay, so this is running in US West 2A. So we're going to go through and we can force it to go to a zone by actually picking the subnet here. So normally if you're going to do this AWS integration, you have to actually manage IAM roles also, and that gets really fiddly. And so that's something that we're going to actually skip right now. And unfortunately, what I'm doing here is great to get up and started, but the way that Amazon works is that if you don't attach an AIM role when you're creating the instance, you can't attach it later. What you can do is actually change what that AIM role can do after you've created it, but you can't attach it to an instance that's already running. Let's see, we don't need any of these other things here. You can do network interface, let's see, and then there's user data and stuff. So we don't need any of this stuff here. So we said it was going to be in that. Okay, so we're going to go through add storage. We're going to go through and we're just going to do a 20 gigabyte, or let's do 50 just to be safe. The 8 gigabyte, if you're downloading a lot of images, it's really easy to run out of space with just 8 gigabyte. So we'll do that. We're not going to add any tags. Now we're going to look at security groups here. This is a real gotcha here. So we're going to launch this with, so you have this choice, and this is actually, I think, a usability issue with the way that the launch wizard works, is that you have this choice where you can either select a single existing security group to actually apply here. Oh, wait, actually you can select multiple of them. Oh, cool. Okay. So what you can't do is create a new one and attach an existing one, because what we want here is we have two security groups here, and security groups are sort of like firewalls that are built into Amazon. And so the first one we have is this default VPC security group, and this essentially says that within sort of one of Amazon's virtual networks. Oh, Bob says that you can attach an IAM role after an instance launch. Is that new? Because like seriously, like a month ago I was looking at this and or like 2 or 3 months ago I was looking at this and we couldn't do it. So if you can do that now, that's exciting. My understanding was that you can just change the IAM role. So yeah, something to check out. Thanks, Bob. Okay, so the default VPC security group says that all the VMs within one of these virtual networks can talk to each other. And so it's like what you would expect when you sort of plug two machines into a switch, right? They, or into a switch or a hub, that they can actually talk to each other. If you don't enable this security group, you won't get that. Now, the next thing we want to do is we want to make sure that and the way that this is written is actually kind of weird, because it says all traffic for all protocols and all port ranges can talk to anything in the security group as long as it comes from the security group. So it's sort of self-referential that way. And then the second one says that we're going to let, and this essentially says we're going to allow anybody on the internet. That's the 0.0.0.0/0. So that says everybody. Okay, so Matt says you can't do it, but there is actually, it is described there. New attach. Okay, well that's exciting. When did that happen, Matt? Is that new, or am I mistaken? Am I going crazy? Okay. So this security group says that anybody on the internet can actually SSH into this thing in port 22. Now this is probably pretty safe because we're not going to be giving passwords to anything. But if you want to be extra paranoid, you probably want to lock down the source to the IP address that you're coming from. So if we didn't have the second security group here, then we'd be doing this sort of like create a new one, and there's no way to actually say both new and old at the same time. Okay, so Matt says it's new as of February. Okay, so I'm not going crazy. It's still relatively new. But since I launched one of these previously, I can actually go through and select the existing, and we'll be good there. And now we're going to go through and do a review and launch. It's warning me that I'm not in the free tier. It's also warning me that I set up something for 0.0.0/0, which is okay. We explained that, and we should be ready to go, and we're going to go ahead and launch these things. Oh, now it's saying, okay, you have to make sure that you have your SSH key available. I do have that, and it's loaded into my SSH agent, so we should be ready to go there. And I'm going to go through and launch instances. And so here's the 3 that I launched. If I go here and I look at instances, you can see I have one instance. I named this one Node 1, and it's running. and then we have 3 more that are actually coming online right now. So let's name these things node 2, node 3, and node 4. And we're just doing that just so that we can keep track of them ourselves. Now, the other thing I did is that before, when I set up this original one here, I did not give it that second security group. And so let's go ahead and attach that now, if I can figure out where that's done. Tags, and it's not tags. All right, so now you can, okay, here we go. Security groups, okay, so can I edit this? View inbound rules, okay, for that one. Launch Wizard 1, security groups. I want to do this one. I want to, can I attach the, I gotta be able to attach the security group later. So now you're seeing that like my knowledge of AWS is lacking here. Let me look at the running instances. Okay, so node 1 here, we have tags. That's not what we're talking about. Monitoring, status checks, none of that is what we want. Here's security groups. Is there an edit for that? I thought we could edit that. Monitoring disabled security groups. Action. Okay, so Bob, you know it better than I do, man. Oh, there we go. Look at that. Here we go. Networking, change security groups. There we go. And we want to actually give it the default one. Okay, so now what we've said, yeah, you guys are way ahead of me here. So now what we said is we have 4 instances running. Each of these instances, I can SSH into them, and they can all talk to each other. Now the next thing I'm going to do, and this is just for sanity's sake, is that I'm gonna create sort of like aliases for these. So I actually have this file here, node2 equals this. Now, lots of folks, when they're doing this stuff in production, they'll then, have this all be driven by sort of automation, and they'll program Route 53, and they'll redirect that internally so they can actually use real names for stuff. This is one of those things that was a real pain, so that when we were designing GCE, every VM has a name by default. You have to give it a unique name, and that actually turns into the host name, and we actually provide DNS for you for that. But here in the Amazon world, it's a little bit more difficult. So now I'm going to go through and I'm going to source that cluster.sh. And so now what I can do is I can do SSH Ubuntu, because that's the user here, at node 1. And look at that. I'm actually into my node. So that's great. Can everybody see this? Oh no, look, my thing here, it's not showing the last thing. Okay, so my YouTube chat, I changed some of the CSS that I'm doing here. I'm going to fix this real live. You guys can't see what I'm doing here. I apologize. So I'm using, here, I'll put it over here. I'm using OBS to do this stuff, and I mucked with it, and boom, 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 boom. I actually wanted it to be at the top. We want to do bottom, and we do bottom, and then I do OK. And that reloads, and okay, now we can see the latest thing. It scrolled off. Okay, all right. So sorry, we're like doing CSS, we're doing cloud, we're doing it all. All right, so now we have a blank machine, and we have 4 blank machines that we can actually use. This first one, this node 1, I'm going to set this up as a master. So now kubeadmin right now only sets things up as a master. But only handles a single master. We're working on methods to be able to do HA multiple masters with kubeadmin. And that's coming. It's something that we're investing in right now. And the other thing to be aware of is that if you do a kubeadmin cluster, upgrades are more of a manual process now than we would like. We actually do have a documented upgrade process now, which is great. But it is it's not as automagic as we want it to be, and it's something that we're going to be working on. So the first thing we got to do is we got to get Docker installed on this thing. And for Docker, Kubernetes, there's the only version of Docker, the latest version of Docker that's actually been Wait, this is, okay, so I'm gonna do sudo -s. Okay, so I'll explain what I'm doing. So the only version of Docker that's really been qualified is 1.12.6. Newer versions probably work, but it hasn't been something that folks have really been beating on. The biggest issue here is that Docker 1.13 introduced a default setting in how they configure IP table rules, which sometimes results in not being able to have your containers actually talk outside of Docker. And it's just the way that the Docker networking system interacts with the way that Kubernetes networking interacts. There's some workarounds there that can get you past that, but the safest thing to do right now, and what a lot of folks are doing, is just running Docker 1.12.6. So what I'm doing here is we're going to add the Docker apt repo here, and I'm stealing this out of the Heptio Quick Start. But essentially what I'm saying is I now am grabbing, you know, and doing all the right stuff so that I can actually download the official Docker packages. And then we're gonna grab the version of the Docker engine that we want here. So we're gonna do apt get update. Apt get install that version of Docker. And that's gonna do some magic. And if we do it right, maybe, let's see. All right, so there we go. So now we have Docker PS. Okay, and so those three commands here, and I'll put this all in a gist later for all y'all. So let's see, so we ran these two commands here, because we're gonna have to do this on each of the other machines. And so I'm just gonna capture this into a new file here. Wait, why did that? I want to do a new, there we go, new. All right, and then we did apt get install. All right, so those are those three commands here. Let me make that a little bit bigger so that y'all can see that. And we don't need that. Okay. Okay, so now we have Docker installed. That's great. Now we need to get Kubernetes components installed. And so for that, we're going to actually go into this thing over here. That's this web page called install kubeadmin. And it documents all the ports that you need to open. But between all the machines, we just had everything talking to everything. So the next thing we're going to do here is we're going to install the apt repos for Kubernetes. This is an evolving story, but we're going to go through and add the GPG keys, do that, and then essentially cat this out. And then we can do an apt get update here. So Bob says I missed an apt get update. Did I? I think we're good. We got Docker installed. We got the kubelet and kubeadmin installed. I think we can install a kube control here also. Okay. Oh, kube control. Look at that. All right. So now we have everything installed here. So let's copy this. Oh, in my documentation here, I forgot the apt get update. So, and let me put some comments. Install Docker. Install Kubernetes components. There we go. Okay, and we're going to have this be stuff.sh. All right. Oh, look at that. We get syntax highlighting and everything. All right. So that's up and running. So now we are ready to go. It turns out that the next thing is that we have to initialize the master. And so that is simply, as root, kubeadmin init. And this is going to do a whole bunch of stuff here for us. And I'm going to explain step by step. We're going to go through each of these things, and I'll actually explain what each of these lines is doing here. So it says kubeadmin is beta. Please do not use it for production clusters. It's actually pretty stable at this point. You could probably do worse. I think the biggest reason why we say that it's in beta is that we want to make sure that all the features that we're using won't change, and that all the features that we're using have been marked as being generally available. And we also want to make sure that the command line and the instructions around kubeadmin won't change, because we're viewing for this particular thing oh look, it actually worked. Okay, phew. I was kind of getting worried there for a second. We're viewing the command line arguments and how you actually configure kubeadmin as being part of the surface area that we want to make sure doesn't change. All right, so let's go through some of the stuff that's going on here. So it's telling us that we're using Kubernetes version 1.7.3, which is great. That's really early. I mean, that's really, really good. And in terms of authorization, we're setting up the node authorizer and the RBAC authorizer. And so what this is RBAC is the general sort of role-based access control. We had an episode on that a couple episodes ago. And so if you want to learn a lot about that, that's the place to go. kubeadmin does this by default. We wanted to make sure that kubeadmin was as secure as we could reasonably make it. And then the next thing it's doing is it's actually doing the node authorizer. And so this is a change with Kubernetes 1.7 to use a special authorizer that does things that aren't easy to express in RBAC, so that nodes only get access to the resources that, essentially kubelets only get access to the resources that they need. And so it starts locking down the view of information that each individual node in the cluster actually has. And then let's see, and then there's this warning here. We'll talk about the tokens in a little bit, but there's this warning that starting in Kubernetes 1.8. Yeah. So okay. So Devanam is asking, this does not set up the cloud providers in AWS. Yes, it does not. You're correct. When we started the show, I was saying that that's one of the things that we're not going to do now. It actually does get a little bit tricky to set up cloud providers. It just gets fiddly because there's more parameters you have to manage, and you have to make sure that you set up AWS correctly. One of the other real gotchas is that especially with the node authorizer, you have to make sure that the names, because the host names all line up, because sometimes you'll use fully qualified domain names, sometimes you'll use smaller ones, so it's like making sure that all the names line up is really necessary with 1.7 and Amazon. So this warning here, when you have other nodes trying to join your cluster, they use this token, and down here you can see what the token looks like. And we made this decision earlier on to have that token not expire. And that's the default right now in Kubernetes 1.7. We're going to be changing that to be sort of more secure by default in 1.8. So in 1.8, that token will by default expire after 24 hours. There's a command line flag that you can actually say that says, hey, I want this token to live forever, or I only want this token to last 30 minutes. But right now, the token that we just generated will last forever. And I'll show you later how we can actually create and expire and manage tokens, because that's something that you can do with kubeadmin. Okay, now the biggest thing that kubeadmin does for you, one of the things that is really nice, is it helps manage making sure that each node can talk to the API server in a secure way. So it does, if you go through sort of like the Kubernetes, the hard way stuff, one of the hardest things to do is to set up all the certificates and make sure that they work, that they have the right names in them, and that they're registered. And it's really easy to take shortcuts where you say give every node it's the same certificate, right? What kubeadmin does is it automates a lot of that. It automates it in a relatively secure way, and it sets it up such that each entity in your system actually has its own unique certificate to actually communicate back to the master, which enables us to start locking down such that nodes don't see or aren't exposed to more information than they really need. So to that end, Kubernetes has a built-in certificate authority, and we're initializing that here. And so that's where we do generate the CA certificate and key. And then that's the certificate authority, but then the API server, which is that main component that has essentially become sort of the center of the Kubernetes system, it needs its own server certificate. And so we're generating that also. And we actually say we're going to give it a whole bunch of names. We give it this name, the IP address, Kubernetes, Kubernetes.default, so all the expanded names that you might talk to this thing through. And then we also give it the explicit IPs that we know that it has. And so this is smart enough to figure out that we have two IPs. We have the internal IP, but then we also have this is the internal IP. And then this, no, actually, am I wrong? I'm confused. So this is the 172 is the internal IP. Okay, where does the 10.96 come from? Where did that IP come from? Am I confused? I'm crazy. Is that my external IP? But I thought 10-/8. So there's the private IP. No, there's the external IP. Okay, so I'm not sure where that 10.96.0.1 is coming from. That's a really good question because I'm not seeing it show up here. All right, I'm gonna look into that and actually see where that's coming from. That confuses me. Oh, that's the cluster IP. Yes, Pratik, you're way ahead of me. Okay, so So this is so that when you talk to the API server from within the cluster, this is going to be the cluster IP that you use to actually talk to it. You guys are good. Good job. So yeah, you can see how hard it is to get this stuff right if you're trying to do it all by hand, but it just happens automatically with KubeAdmin. And then the API server, there's places where it actually talks to itself, and so it needs both a client certificate and a serving certificate. And then there's other certificates that we need to create for service accounts, which actually don't base off the same CA, unfortunately. And then there's this front proxy CA certificate and key, and this is for API aggregation. I'm hoping that over time we can actually collapse this into one sort of certificate authority tree. And there's some efforts and some thinking around that. But right now we end up with sort of a set of certificates that you need to deal with. Now all of these things end up in one directory here. Let's see. So let's go ahead and look to see what's in that directory. Not cat, ls. So yeah, so you can see here is the API server certificate and key. Here is the client certificate. Here's the CA. Here's those proxy ones, and then here's the service account key and public. Why is that one called pub? What is this? API service account token signing key. So this is actually not a certificate. It's actually just a plain key because this actually creates RSA JWTs. So it's not using X509 certificates. So yeah, so you could break out OpenSSL as a toolkit and start cracking those open and see what's happening. But the biggest thing you want to make sure here is that you actually have the serving certificates here are the ones that you're going to be using to talk to the API server. If there's going to be other names that you're going to use to talk to the API server, like let's say that you give it a DNS name inside of your own infrastructure, or if, and this is what we do with the Heptio Kubernetes Quick Start, if you're going to be sort of having an external load balancer that's going to tunnel through to your API server, you want to make sure that this certificate is also good for what other names you may actually be using for the API server. And there is a flag that you can use to do that, and it's here in the reference documents. It's the API server certificate extra sans. Sans is X509 speak for subject alternative names. So what other names? So like here's the example of like if you want to have like myproductioncluster.mycompany.com, you can go ahead and actually put that there. And so that's how you can expand the set of names or addresses that your API server is available to. Okay, so now we get all these certificates set up and we haven't actually started anything yet. So the next thing we do is we write a bunch of files into etc Kubernetes. So let's do ls etc Kubernetes, and this goes into etc Kubernetes manifests. And this starts up all of the control plane components. So we have etcd, which is the database for Kubernetes. We have the API server, the controller manager, and the scheduler. So those are the four main components. And if you look at one of these things, so let's if we look at one of these things, it's a pod definition. And so we're actually using a pod definition to describe how we want to run the Kubernetes API server, which is kind of wacky. And you actually see here's all the command flags that we're actually giving to this thing. And you can see we'll do things like stitch in all the various certificates and all that. So all of the, and then here is the actual Docker container that we're using to run the API server. So this is kind of surprising because we're actually using Kubernetes to run the control plane for Kubernetes. So this is one kind of self-hosting. It's not sort of the full type of self-hosting that we've talked about and that we're sort of looking at moving forward for Kubernetes. What's actually happening here is that when I went through, and we'll sort of rewind the clock here, and when, oh man, my scroll, oh, I didn't set my scroll back. Okay, when we did apt-get install with the kubelet, it actually started the kubelet up. And the kubelet actually has sort of two modes of operation that it can actually work in. So the first mode is what it usually works with, where the kubelet reaches out and talks to the API server, and the API server tells it what should be running, right? So essentially the kubelet is essentially a remote agent for the Kubernetes cluster itself. There's this other mode that the kubelet runs in, and these things can coexist at the same time, but there's this other mode that the kubelet runs in where it is a where it actually takes its marching orders from files sitting on local disk instead of actually taking its marching orders from another from a server over the network. And so these things are called static pods. And they're defined by things that are sitting in files versus actually talking to the API server. And so what we're doing here is the only thing that's managed by systemd on a kubeadmin cluster is the kubelet itself. Everything else is actually managed using either these static files or things that are actually running on the cluster itself. And so if we go through and so we do that, and then it waits for all these things to actually come online. So this is where it says waiting for the control plane components to become healthy. And then it does a couple other tasks like installs the user token that we talked about, the join token, configure some RBAC rules, and then applies on some sort of add-ons that every cluster needs. And this is the kube proxy and the kube DNS server. And so let's look a little bit further under the covers here. If I do, and I am not a, system control, I'm a system cuddle. There we go. Status kubelet. We can actually go through and actually see what's happening with the kubelet. Now, what happens is the kubelet actually sits around waiting to actually see what's happening. Okay, so Giovanni says, are the manifests needed just to bootstrap the master? Are they migrated in etcd somehow, or should they always be left there to start things as expected always? So it's actually the second one. So right now, the only way that we run is via those manifests that are sitting on disk. As we look to evolve how kubeadmin works, we're looking at doing something where we start up in some sort of mode like this, and then we essentially, using HA, we start some other masters that are actually scheduled by Kubernetes, and then we can go ahead and delete these manifests. And at that point, Kubernetes is truly running on top of Kubernetes. One of the problems there, and this is one of those sort of hacky workarounds to get that working, is number one, you have to have a stable way to actually talk about these things. And so right now, because we're running on one master, we always know where that thing is. And then the other problem here is essentially if you shut everything down and then bring it back up, how do you know to actually restart that? How do you start the engine again, right? It's like, and so there's this feature that is the CoreOS guys have blazed a trail here with this project called Bootkube. but we're looking at building some support into Kubernetes and into the kubelet itself. It's this thing called kubelet checkpointing, which means that if the kubelet dies and comes back for a certain set of pods, instead of actually reaching out and waiting for the API server to tell it what to do, it'll say, well, I'll just run the pods that I was running last time I was running. And so that way, if you go to a total sort of lights out situation and the entire cluster is shut down and you bring it back up, it can rebootstrap itself. So we're not quite there yet. Yeah, as Tim says, we're working on it. It's definitely the direction that we want to go. So here's the only thing that's being managed by systemd is the kubelet itself, and then we're using the kubelet to run all the other components. So that's pretty interesting. Okay, so now what we have here is, so it's applying these add-ons, and then it gives us some stuff that we can run here. And we're going to exit out of, and we're going to do this stuff here. So what this says is we're going to create a directory, this .cube, and we're going to copy the kube control file into this thing and then own it so that this particular user can use it. And so this sort of moves us from sort of a root level thing to the point where we have now the credentials so that we can talk to our own cluster. And if we do this, I'm going to go through and I'm going to flash creds on the screen, which means after this live stream, I have to take this cluster down because somebody can go back and read stuff. But if we look at .cube config here, you can see we have things like, here's the cluster CA certificate. Here's where the server is. And then here's my client certificate that I'm using to talk to this thing. So now I can do kube control get nodes. And you can see I have one thing and it says not ready. So that's kind of confusing. Well, it's not ready because we haven't installed the network yet. So we'll get to that. All right, so let's go through and oh, not that. And let's actually, so I open another tab here. So here's node 1. Let's cd tgik. I'm going to source cluster. And I do sh ubuntu at node 2. Okay, so now I'm SSHing into my node 2. Okay, and so this thing's starting clean also. So we have to do some of the same things that we did before. So let's just go through and install everything. Oh, that didn't work. Oh, I have to. So I'm cheating. I'm copy and pasting all that stuff in. Oh, it didn't like that. Okay. So, oh, I need to do. What is this thing? So let's see. Did we do this? Did we get there? Yes. Okay. Sorry, I didn't actually give it all the -Ys and stuff so that it was all automagic. Okay, so we're installing Docker now. And then we're going to go through and install. So this, let's give this the -Y. I don't think there's anything else that's interactive here. Okay, and then we'll install the kubelet and stuff. Wait, well, that didn't work. What did I do wrong? Okay. Okay. What? Did this error out or something? So now, sorry, I'm moving really fast here, but this is essentially the stuff that we did last time. All right, and you can see that this is relatively easy to get the prerequisites on board. It's relatively easy. Okay, so now here we are. We have another node. It has Docker installed. It has the kubelet installed. So we're ready to go. Let's go through, and if we actually rewind here, oh no, oh noes. Okay, so I actually let it scroll off, and I shouldn't have. So I will recreate it. So there's this line there saying, here's what you do if you want to join. Qdadmin token. Token list. So this thing, okay, so that's the token that we lost. So here it's kube admin join token, And then there's the server that we want to talk to. And if we go back here, we can copy the token. And so this is the line. So after you run kubeadmin init, you end up with a join line, and this is the join line that we want to use. So actually, since I don't have to do that for the next node, we're going to go through and we're going to create a new file, and we'll actually just save that away. And our goal out of this is that we wanted this to be something that was short enough that you could easily copy and paste it. All right, so now this node has joined the cluster, and if I go back to that master and do kube control get nodes, I'll see that now I actually have that other node there also. So that's pretty cool. So let's actually check out what this thing was actually doing. So it runs a bunch of pre-flight checks. So this is making sure that you have Docker installed. It tries to connect to this API server. Now it does a whole bunch of stuff here to actually figure out how to connect to that thing correctly. And so we did some sort of fancy dancing so that we could make this command line be as short as possible. Devanam was saying that the kubelet pod API is in a proposed state. So that's the thing to be able to do the checkpointing. And so the first thing that we can do is that we reach out to this thing, and without having any authentication at all, we can actually download a certain file. It's a config map that's sitting in this special namespace called kubepublic. And that file has all the information about the cluster. And so we'll try and curl that in a second. And then what we do is we use this token to be able to actually verify that information. And so we at least know that whoever we're talking to on the other end has the same token that we do. There's going to be, coming in 1.8, we're doing some extra work to lock this down even further, such that we know not only that the other person has the token that we have, but the hash of the certificate authority that we're using is the same. And then with that, now we actually have enough information that we can establish a secure connection, and we actually trust who the server is. And then we use the certificates API, where we create a certificate signing request. We create our own key. We create a certificate signing request. We give that we drive that to the server. The server says, hey, everything lines up. I like the token. I like what they're asking us to sign. It automatically signs it. And then we can download our signed certificate, and we can use that to actually now configure the kubelet so that it can talk to the API server. And so the whole goal is that we want to establish bidirectional trust to the point where we can finish configuring the kubelet so it can talk to the API server. Coming in 1.8, this whole idea of creating the CSR and registering it with the server, that's going to actually be moving from code that's actually happening in kubeadmin to code that's actually happening in the kubelet. And the big reason why we're doing that is so that we can automatically rotate these certificates, and the kubelet can actually use shorter term certificates and rotate them as necessary. So let's go through, and we're going to actually go through, and I think if I can remember, curl v1 namespaces. I think I'm going to get this wrong. Kubepublic cluster. Kubepublic. Cluster maps. Config maps. Info. Okay, Andy's saying it's API/v1. I missed. Okay, so the error here is it's saying I don't trust the certificate that we're seeing here. So we're going to actually give this a -- insecure. Okay, yeah, so this is the information that kubeadmin reaches out, and you can see in here, here's their certificate authority data. So this is enough that we can actually know what we want to use to connect to the server. And then there's this other thing here, which is essentially a signature. And so you can take the token combined with essentially a hash of this stuff, and it uses an HMAC so that we can actually make sure that this piece of data is signed with a token that, that the kubeadmin has. So that's kind of cool. All right, so now we have 2 nodes. I'm going to skip ahead a little bit here. We can do the same thing for our other 2 nodes, but I think we're running out of time. The next thing that you absolutely have to do is install some sort of networking solution. And so you can see here that there's a whole bunch of things that you can do. I'm going to use, let's do Weave to begin with. And most of these networking solutions have, it's just as simple as actually doing a single kube control apply command. So we don't want to actually, like you know how like everybody says it's really bad security policy to curl and then sort of like pipe it to bash? Well, running a kube control apply to some random address is kind of like the Kubernetes equivalent of curl to bash, pipe to bash. So you really want to actually know what you're getting yourself into here. Oh wait, what did I do wrong? -O. What am I doing? Am I forgetting my curl commands? Okay, so Pratik, how is Node 2 able to get the data from API server? Can any node query this data, or is it because it's in the cluster? It turns out that anybody who can reach the API server can get that one snippet of data. There's really nothing private there, but we do that for this bootstrapping situation. That's why that's in a namespace called kube public. Okay, so why am I doing curl? My curl voodoo is actually curl this thing. Okay, so what am I doing wrong? Oh, it's a redirect. Yes. Thank you. That always gets me. So if we do a V here, what you can see is that it's actually giving us, it's returning a 302 found with a location header because they're hosting it on GitHub. And so we have to give it the -L. Okay, so it turns out that to install Weave, it's installing, like it's doing a service account, it's doing a cluster role binding, and then it's installing a daemon set. And so the daemon set is going to run this Weave cube image, and it does a bunch of stuff there. So, okay, I trust that. Why not? Okay, so let's do kube control apply -F. Yes, I did mean apply. I think my Y key is getting stuck. Okay, so this created service account, cluster role binding, and then the daemon set. And we could actually look to say, okay, what does the cluster role need to do? This needs to get, list, and watch pods, namespaces, and nodes, and then get, list, watch network policies. So this actually makes me feel a little bit better here because I know that whatever I'm running now, you know, the only thing it can do within the cluster is actually read only to stuff. So this actually can't see secrets, and this can't modify anything else. It's just using reading stuff to actually, it can just read stuff so that it can figure out which pods are running on which nodes and such. And then the other thing you want to look at is like, okay, so it's doing some other wacky stuff, like it's doing some host mounts. So that's not great. So, you know, I got to trust it enough that it can actually do some of that stuff. But this sets itself up using this system called CNI. So if I now do kube control get nodes, now you can actually see that these things say that they're ready, which is actually really good. And one of the things is that if I now bring up node 3, it doesn't matter what order I do these things, and node 3 will come up, and if I do the cluster networking first and then add nodes, or if I add nodes and then do cluster networking, doesn't matter. Everything will sort of like make itself okay. And so what this does is this writes into etc CNI net. It writes in this configuration here. Okay, so it installs this new CNI provider that just says have Weave do its thing, right? So relatively straightforward there. And so this is how it hooks into CNI. So now we actually have a cluster, right? So we're up and running. That's good. We don't have the integration with the cloud provider. The only way I can hit this cluster is from my local machine. I mean, when I actually SSH into the master. So that's kind of hokey. But let's see if we can actually improve out of that. So now I'm back to my laptop. I'm going to do an SCP from Ubuntu and that thing. Let's see, we're going to do .cube config to cube config, okay? All right, so now I want to, so I actually copied down the cube config from the folder there. Let's go ahead and open that puppy up, and you can see that the server that it's looking for here is that's not going to work from my local machine. So I'm going to go ahead and edit this thing to be 127.0.0.1. I'm going to do it over localhost 6443. Everything else should work the same. Now let's do SSH. To SSH Ubuntu. And I do local, was it 6443 to localhost. I might have my, does that work? And now if I open a new window, oh, that's the wrong key combination there, sorry. There we go. Actually, that's not what I want. Let's do big font, or bigger font. TGIK. I can do cube control fig equals cube config, cube control get node. Oh, okay, so yeah, so here's the problem. So this thing is confused because it doesn't like the fact that I'm referring to the certificate doesn't match up, right? Because I'm talking to this thing at localhost, and the certificate's actually saying, well, no, it's only these other things that are working there. So let's see, what else did? Is there a way? Does Cube Control give you a way to do this? You know what? This might be a good feature to add to the Kubernetes client. A way to say, like, here's the host name that I want to talk to this thing as, and then use that when doing the TLS, because I think this is a pretty common problem. So what's the right way to do this? So let's nuke it from space. Let's do sudo nano etc hosts. And we'll actually call 127.0.0.1. We'll call this Kubernetes. And yes, exit. Somebody have a suggestion? Yeah, so I essentially basically need curl's resolve for it. No, Kube Control Proxy won't work because proxy only works once you actually have a connection back to the API server. And so we're trying to get that up and running the first time. And there might be an option there somewhere. I'm going to have to do some research on that. I'm going to go ahead and take a note. So sort of alternate host names. I bet you there's a bug there. I bet you I'm not the only one to hit this, and there might be a feature that's already there. I'm just not aware of it, because usually you plan this stuff ahead of time, and you actually sort of like when you first create those certificates, you make sure they have the right values in there. Okay, so this should work. Let's see. Oh wait. Okay. Oh, now I have to go back here, and I have to change this to Kubernetes, which I know is one of the things in this certificate, and it should work. Yes! Okay, cool. So now through an SSH tunnel, I'm connecting to my master, and then I'm talking to the Kubernetes API server through that. And so I'm essentially tunneling, and then within that tunnel, I'm doing mutual TLS and authenticating to the other side. And so, yeah, so this whole process that I worked through here, this will work with pretty much any set of machines that can talk to each other, right? So you could run this on Amazon, you could run this on a stack of computers sitting in the corner, you could run it on you know, name your favorite cloud. The one thing to keep in mind, though, is that while connections between pieces of the Kubernetes control plane are authenticated, like sort of the way that the kubelet talks to the API server. Well, those things are authenticated. Any traffic for applications that you're running on top of Kubernetes aren't going to be authenticated by default. So if you're running on something like DigitalOcean, where like there really is no private networking between the different nodes, you're going to want to think about that, and you're going to want to take that into consideration. Using something like Istio is one way that you can actually then have all of your workloads use mutual TLS, or you can actually, as you configure your nodes, you can do something like a VPN mesh to go ahead and do that. Now, obviously, in most situations, you won't want to go through what I just went through here. There's a ton of essentially systems that will help you get Kubernetes up and running. Some of those things will not use kubeadmin, and they'll do their own thing that essentially does a lot of the similar things to kubeadmin. Not all of them will make some of the same trade-offs. There's a lot of folks that don't like the idea of using Kubernetes to run Kubernetes, and so they might do something like run the API server under systemd directly versus running it under the kubelet that's running under systemd. And that's a perfectly fine way to run Kubernetes. There's also a set of systems that are built on to essentially do everything that I did, and then they also use Kubernetes as part of it. And so the Heptio Quick Start is one of those things. And then there's a host of projects, and we're looking at making kubeadmin even more flexible so that you can run different parts that make sense for you but not other parts, so that we can integrate this stuff with more and more ways that people want to get Kubernetes up and running. So with that, that's all I had today, and we're right at 2 o'clock. So first of all, thank you very much for joining and sticking with me here. Hopefully you learned a little bit. I always, every time I do one of these, I always hit some sort of stumbling block and I learn something myself. So that's kind of fun. These are not super well scripted, so so it's always a little bit of an adventure. Let's see. So Andy, who was chiming in here. He's working on a blog post that we're going to get out there that talks about what does it take to actually write a controller for Kubernetes. And so I'm going to work with him to make sure we get that out there pretty soon. And then in a future episode, we'll go through that and we'll actually write some code and we'll play around with that a little bit. So that's one of those things that I definitely want to get to. So keep the topic ideas coming and let other folks know. Subscribe if you don't already. And thank you so much for tuning in. I really appreciate it. See y'all later.